So we're going to go through trig ratios and special triangles. And what we're going to try to find is our trig ratios for sine, cosine, tangent, and we could even actually put in, if we like, cosecant, secant, and cotangent, just so that we're covering all of this. Okay. So first off, we kind of want to relate this to a special triangle, though I don't really know which special triangle this is going to relate to off the bat. Maybe I can draw both of them out, see if that gives me a better idea. But I get the feeling what's going to help me a little more in this question is actually possibly converting this to degrees, because sometimes, depending on what we work with more often, we're stronger with one of the units of measure than the other. So we have our one triangle here, and do you recall this one? That's an equilateral one. Mm-hmm. Do you remember what the ratio is in it?
1, 1, and root 2.
Yeah, that's right. And what would the degrees be here?
45.
Okay, so 45 degrees. Do you happen to know what they might be in radians? And we can test this, right? If we're not sure off the top of the head, let's actually go about finding out. So 45, and in order to convert to radians, what do? You recall? We have to multiply by an amount.
Pi over 180.
Yeah, pi over 180. Great.
I think I just figured out how to do this question.
You think you got it? Okay, so why don't you talk me through it then?
Okay.
This would become, okay. And then where do we go from there?
That would become 9 pi over, or actually no, it could be 5 pi over 20.
Oops. So you divided both by 9?
Yeah.
So 5 pi over 20. That's right.
And then I get that could be pi over 4.
Yeah, great. Yeah. So we just discovered that 45 is a pi over 4. Okay. And let's kind of think about this measure here. I'm just going to help you along and then get you to talk me through. If I were to set this up, where do you think this 7 pi over 4 would end up falling?
Well, I converted 7 pi over 4 into degrees, and that...
Oh, did you?
Yeah.
Okay, what did you get when you converted it to degrees?
I got 315 degrees.
Okay, so that should give us a pretty good idea. What quadrant would you think we'd be in?
In 4.
Yeah, that's right. We'll be in quadrant 4. Okay.
Yeah.
So 315, and 315 is... Oh, actually, okay. It's going to be what? Directly in between?
Yes.
Yeah, that's right. It's going to be directly in between. So, from here, what can we do? This is directly in between. We'll call this our 315. What can I do from here to find out these ratios?
Well, it's the special triangle with the 1, 1, and root 2.
Okay, 1, 1, and root 2. Great. Okay, so let's write out our ratios. Do you think you can start building them?
Yeah.
Okay, so if I were to do sine, how would I write it? What would I do?
Sine of 315 degrees, or 7 pi over 4.
Okay, so we'll call it 315 degrees, or actually let's do it as the radians. 7 pi over 4. What do we do from here? What is this the equivalent of in a ratio?
The ratio is equivalent to sine of 45 degrees.
Okay, and how do we set this up as our unit though?
Well, the sine of 45 degrees would be just 1 over root 2.
That's right, it's opposite over adjacent. Great, so that's 1 over root 2. So you set up sine. Let's say we do cosine. Same idea, or same value in radians. What will this become?
Also 1 over root 2.
Okay, and then tangent?
1.
We have opposite over adjacent. Yeah, you're just right. Okay, what if I did the others? What if I used cosecant? Cosecant is what in relation to these three? Do you recall?
1 over sine theta.
Yeah, that's right. So it's 1 over sine theta. So cosecant of 7 pi over 4. Do you know what that would be equivalent to?
Root 2.
That's right. It's just the what? How can I find a shortcut to go from this answer to this answer?
Reciprocal.
Yeah, that's right. Which means, what's the next one on this list?
We can do that.
Secant,
Is
yeah.
Also root 2.
Okay. That's right. And then, what's special about cotangent?
It's 1.
Yeah, it's the exact same thing, right? Perfect. You got it. Well, that's everything they're asking for that question there. We did find everything, but we have to keep in mind what quadrant we're in, right? This quadrant here. And this technically relates to the CAS system. We can use the CAS system to really find this information quickly, or we can be intuitive with the numbers we found. Do you remember what the CAS system states, like in quadrant 4?
Well, it states which ratios are positive
Yeah.
in which quadrants.
And what would be
Cosine?
Yeah, so we have C, A, S, T, right?
Yeah.
So our cosine will be positive, which means, and it makes sense here, technically this value, okay, you can kind of think of it as a negative 1, right? Because we've gone down 1 in terms of our y-axis, right? So our sine, if we're talking about sine, we have opposite over hypotenuse, and that's a negative over positive, so we have negative 1 over 2. So technically our answer here should be negative 1 over root 2, and that makes sense, sine is a negative value. Our cosine is adjacent over hypotenuse, and this is a positive value and a positive value. Well, our cosine is positive, just like the CAS system tells us. And our tangent is opposite over adjacent, which means it should actually be negative 1. Okay? And that's what our CAS system says. So with that being played out, how does that affect our 3 other ratios? Would cosecant be positive or negative?
Negative.
Negative, that's right, because it's really just the inverse of our sine ratio, right? So it still stays a negative. It's not like a negative circle. That's hard to see, but it's negative root 2. Our secant,
It stays positive.
yeah, and our cotangent
Is negative.
Yeah, that's right. So that's actually really important too, that we do keep in mind what quadrant we're in, because that changes our ratios for our questions.